Hey guys, today we're going to talk about the early periodic tables. As science progresses, scientists are able to refine and change their ways of thinking, and this was shown in the use of the periodic tables. Aristotle was the first person to attempt to categorize the early elements. His categories consisted of just four things: earth, air, fire, and water, and he simply listed the items underneath those headings. So if he had earth, he would then have clay underneath it, and then he would have carbon underneath it. So he would simply have four categories, and in each category he would just list the items that fell into that category. From there, we have the first periodic table, which was an attempt to organize elements in the 1700s. So over on in this photo, we have examples of the names of the elements and some characteristics of those elements. So understand that obviously this is not in English, but Lumiere stands for light, calorique stands for heat, oxygen, etc. So here are the lists of the names of the elements with some characteristics for certain elements. So oxygen has more characteristics than phosphorus does or carbon does. Instead of an organized table, it was just listed in the categories. So again, very similar to the previous one, these categories consisted of metals and nonmetals, but some of the elements that we looked at were later considered to be compounds. They weren't the individual elements, they were two or more elements bonded together, but they were seen so regularly in nature that they were assumed to be a pure element. Over the next 100 years, many scientists aided in continuing the organization and categorization of elements. First, they were categorized based on weight. Then after they categorized them based on weight, triads were determined, which were sets of three elements that had similar characteristics. From there, we were able to create a table, and John Newlands was the first person who adjusted the long list of elements into this table idea. First, he listed the elements by weight. Then he noted that the first and the ninth elements had similar characteristics. The second and the 10th, the third and the 11th, etc., etc. So he placed those in vertical columns. Since they had similar characteristics, they were in the column together. So looking at this table, we have hydrogen with lithium underneath it, which is the same as our current periodic table. We have fluorine with sodium underneath it, which is not the same as our current periodic table. Chlorine and potassium, cobalt and nickel in the same category with copper underneath. So as you can see, he didn't leave spaces. He used only the elements that were present at the time and did not know to leave spots for new elements that have yet to be found. Mendeleev was a person who ended up fine-tuning this table. He rearranged some of the elements so they fit into the columns with matching characteristics, but he was also able to leave blanks where there should be an element based on missing characteristics, but it may not have been discovered yet. This allows scientists to make predictions about unknown elements, which were almost always found to be true. So for example, we had hydrogen and lithium. Underneath lithium, we had sodium and potassium. Next to lithium, we had beryllium, and underneath, maybe we didn't have that element yet, but we knew calcium was here. So this spot was left blank because they knew that the mass of calcium was too much larger than the mass of sodium to go directly next to it, so it had to go down one. So these characteristics in the vertical columns were able to tell us we're missing a mass, but we know that we need an element here, so we're going to leave that open until we determine what that element is. So again, for this example, we have hydrogen, lithium, sodium, potassium. Underneath potassium, rubidium, and then cesium. In the next column, we had beryllium, magnesium, calcium. Zinc was over here, even though he's not over here yet. Bromine, cadmium, barium, and then these two elements were unknown. That's why they were left as blank. So anywhere you see a little dash, that's where there was an unknown element. After Mendeleev, other scientists fine-tuned this periodic table a little bit more. Some discovered the atomic number, and we know from the last unit that the atomic number is the number of protons. Some discovered what the noble gases were and where they went in the periodic table. This is something we're going to talk about in the next set of notes. All fell within the basic structure that Mendeleev introduced, but with slight adjustments at times. For example, there are some elements that, when they are listed in terms of mass, their protons do not go in order. So those were flip-flopped in the other direction. So for example, antimony has a mass of 121, and that's in the bottom right of the periodic table with the symbol of capital S, lowercase b. Tellurium is directly next to him, and he has a mass of 127, and that's the symbol of capital T, lowercase e. But iodine comes next, and following the mass trend, iodine should have a mass bigger than 127. But in fact, his mass is 126.9. So the mass didn't increase, but because iodine has 53 protons in the nucleus, iodine was placed to the right of tellurium to make sure that it's in the right order. Other scientists also introduced synthetic materials. They were added at the end of the periodic table because generally their masses are higher and they are radioactive. So those were placed in the bottom right corner of the periodic table, and they start at element number 93 and go straight through to what is currently element 118. So here's a look at the new periodic table. This is a periodic table that has been fine-tuned already. It has already been organized and placed. So we have these pretty columns, and everything in this red column has the same characteristics of everything beneath it or above it. Everything in this column has the same characteristics. This middle section, which is the transition metals, have slightly differing characteristics. They vary in reactivity, they vary in masses, and they vary in valence electrons. But again, everything here has same characteristics, etc., etc. So the early periodic tables went straight from just being lists and categories to based on weight, to based on protons, to now leaving empty spaces for unknown metals or unknown elements that have yet to be determined. So we went through a progression. We learned from our discoveries and we adjusted our theories and our thinking through that process. So the next thing that we're going to look at is specifically what is organized in the periodic table, how it is organized in the periodic table, and the trends that we see. So I'll see you next time so we can look at that.